Welcome back to Bytes of Pi. This video is going to cover the second part of inheritance concepts within Java. Let's get started. Inheritance is an object-oriented technique of building additional functionality on top of existing code, so code reuse. In this presentation we'll cover topics like polymorphism, designing for inheritance, and we're going to recover interfaces. We talked about interfaces back in chapter 5. But here we're going to compare them to abstract classes. Why are they different? Before we get into it, I'm just going to remind you of what the difference between compile time and runtime. Whenever I refer to something as compile time, essentially that's the time it takes to convert the text that we write in our editor and convert it into what we call bytecode, or something that the computer will understand. So if I said I had an error at compile time, essentially it's when I have a syntax error like this where I have a missing semicolon. Before I can even run my program, I'll have to compile it, and in the compiler will point to this line and say, hey, you missed a semicolon here. So I'll have to fix that before it can actually finish compiling. Now, runtime means it's something that's determined when your program is running. For example, if the function of an object if you try and call a function of an object that is null, the error is thrown at runtime. So, for example, here I can tell that I'm creating a null object, and then I'm calling the length function of an object that doesn't exist. Now, logically, humans can read that and say, hey, you're going to have a problem here, but the compiler won't catch it. This is all syntactically correct. Everything is fine here. It assumes that you know what you're doing. But when it runs right to this line in code, when you're running the program, it'll throw an error saying, hey, this object doesn't exist. So that's the slight difference between compile time and runtime. So think about runtime when you talk about polymorphism. So polymorphism comes from the word polymorphic, which means something that can take on many forms. Poly meaning many, and morphic taking on forms. As we see with inheritance, which method that is called is determined at runtime. So what does that really mean? So say I have an interface vehicle here, and I can create three new different classes like airplane, car, and boat, and they all are of type vehicles. I can loop through a list of these vehicles. I can add them to an array list, because as long as they are a vehicle that's got the is a relationship, an airplane is a vehicle, a car is a vehicle, a boat is a vehicle, I can put them all in the same collection. So here is my collection of vehicles, and I can loop through them, and I've made a contract called move. So at this point in code, the code doesn't know whether it's an airplane or car or a boat. The only thing the code knows is that there is a vehicle, and it has a contract called move. So we're going to get into a term called dynamic binding. So polymorphic references to termed at runtime is called dynamic binding. So here you can see I'm looping through three different types of vehicles, and it's going to dynamically bind the function. It's probably better to address this with an example. So here's the code. Here I have an interface. Actually, instead of an interface, I've made an abstract class. It does some things. It sets color, but then it also has this contract, something called move. I'm telling the people that want to use my code that vehicles will implement a function called move. So I've created a car class here, which has fulfilled the contract. It's created move, and it's put some meat on the bones of it. It does something. This function does something. It says whatever color car goes vroom. The same thing with boat. I've fulfilled the contract here with move. It's a different move. It does something different because it outputs boat goes splash. Also, same thing with airplane. I've fulfilled the contract here. I'm saying an airplane goes whoosh. So let's step through this in code. So here I have a list of vehicles. I'm going to step through. I've created the vehicle list, and I'm going to create an airplane, a car, a boat, a car, and an airplane. And now I'm going to loop through. I'm going to get the first vehicle. So let's take a look at the first vehicle. The first vehicle is a green airplane. So going to step into this and we'll see which class gets called. Sure enough, the airplane move gets called. Here I am in airplane, and it's calling the airplane's move. Okay, step out of that, and I go to the next one. So here I'm in a white airplane. I'm going to skip over that. Now I'm in a brown car. So here I am in the brown car. Let's step into that and see which one we go to. Sure enough, I'm in the car. So here you can see I'm at the car class. Stepped over into the car class, and it'll say car goes vroom. Boom. So here's an example of polymorphism where I'm calling the same line of code right here, this v move, but because it's a boat now, I'm going to call a different, I'm going to morph into a different function. I'm going to call the boat's move function. Here I am in boat. I'm just stepping through this, and it's calling the appropriate move class for every time. So now I'm back in a car. I'll step over that. You can see a car is printed. I am in an airplane. I should expect an airplane to be printed. Go to the next one, and I'm done. So that's example of polymorphism and dynamic binding. References. So when we talk about inheriting and we're using Java, we can call things called widening references. When you take the ancestor object reference and assign it to a predecessor. So back with our existing example, a car is a vehicle. I can say that I can create a new car and assign it to a vehicle. So that's a widening reference, saying I'm taking this and saying, you know what, I'm using the is a relationship and I'm storing it to a car. Now the opposite can also be done. It's called a narrowing reference. When you take the predecessor object and reference it and assign it to an ancestor. So here I'm taking the vehicle and casting it back to a car. Now notice there's something slightly different. I didn't have to cast it when I widened it, because all cars are vehicles. But you notice not all vehicles are cars. Say if I did this, if the vehicle 1 was in a car but was an airplane, and I tried to cast it to a car, it would fail. So this is a dangerous. So you have to know in code that whatever logic took you to this point, that it is a car at this point. If you don't know, then it's not a good idea to cast it, because if another class gets through, it will fail here because you can't cast a different class. A car is not an airplane, and an airplane is not a car, but they are both vehicles. So here's another limitation when you widen your reference. So just the same example, I have a car and extends vehicle. So here I am, I'm extending the vehicle. But I want to add an additional function called honk. So car can actually honk its horn. The boat can't. We're going to assume that other vehicles can't do this, or if they do, they want to be able to implement it somewhere else. But in vehicle, honk doesn't exist. So if I widen my reference, I say a new car, I create a new car and pass it to vehicle, and I try and call honk on it, the compiler will stop me saying, hey, I'm looking at vehicle and vehicle doesn't have a honk. Compiler will stop you. So at compile time, it'll say, hey, I can't call this, even though the car actually has a honk function, the vehicle does not. So even if the vehicle is a car, you try and call honk, it won't work. If you want to do this, you explicitly have to call to cast. And that's what this thing is we have to cast it to a car. So we're saying this vehicle V is a car, and I want to call car's honk function. Designing for inheritance. You want to design for reuse. When designing a class hierarchy, make sure it's easy to reuse. So when you create your top class, the class that everything inherits from, you want to make it generic as possible. You want to make sure that it can be reused. If I said my top class is Honda Accord. Well, there's not many types of Honda Accords, so I really can't reuse that class. It's a little too specific. But if I said vehicle, well, there's a lot of things that are vehicles. It's fairly broad. So when I'm designing it, I want to capture as many items as I can, as broadly as I can, so that I can share common tasks. The is a relationship. When you're designing, make sure that the relationship fits an is a sentence. For example, an hourly worker is an employee, or an executive is an employee. I don't want to have a super class that says monkey and say hourly worker is a monkey, because it really doesn't fit. It really doesn't make sense in that regard. So whenever you do a relationship, an inheritance relationship, make sure you can say in a sentence, one class is another class. And finally, override when appropriate. So there are certain functions that are in previous classes. For example, you could create a new function that says getMe, which returns a string about the object, but it would make more sense to override an existing function like toString. That's a better fit. So if you know that if you have your inheritance chain and you have a parent, and there's a function in there that would fit what you're trying to do, it would probably be better to override it so you don't have to define that and create a new one, rather than just creating a new one just for giggles. Finally, we're going to cover the differences between interfaces and abstract classes. From our definition in our previous class, it sounded a lot like an interface, but there's a lot of slight differences. First thing is the keywords we use. If you're going to use an interface, you're going to use the keyword implements. So I'm going to create a class that implements the comparable interface. So if you remember back to chapter 5, we talked about inheriting from the comparable interface. But if we're using abstract classes or other classes, we use the keyword extends. So we're extending a specific class. When you implement all methods. When you use, you are required to implement all methods. So if you're inheriting from an interface, you have to implement all the functions, like that move function we talked about in vehicle. I had to fulfill the contract and call move. The same thing is true with abstract classes. If I have a couple abstract functions, I have to implement those abstract functions. The only caveat is, and this is I'm put sort of, is if you're creating another abstract class, then you don't have to. But not many times would you want to create an abstract class from an abstract class. Most of the times you would want to create a new class that you can create that you will be able to create objects for. Here's a similarity. Abstract methods and members. They both can declare abstract methods and members. Now, in an interface, because all methods are abstract, you don't have to write the word abstract, so right here. However, because with the abstract classes, you can put meat on the body of something, you have to put the keyword abstract there. Even though these are both abstract methods, in an abstract class you have to specify abstract. Polymorphic methods. Methods implementation determined at runtime. Just like we showed in the demonstration, whether it was an interface or whether it was an abstract class, they both determine the method at runtime. Inherit from multiple. Now this is another key difference. If I have an interface, I can implement multiple interfaces. So here I created a person, and I'm implementing the comparable interface and the serializable interface. As long as I fulfill the contracts for both of these interfaces, it's good to go. However, abstract classes can only inherit from one class. A regular class can only inherit from another class. So you can only use extends. You don't see a comma piece, comma, game board or something like that, because it can with classes and abstract classes you can only extend one class at a time, only one parent, where interfaces can have many parents, and that's not a problem. Can a method with a can they have a method with a body inherit from multiple in a same class? So interfaces, you cannot do this. I can't put meat on the body. They all methods in an interface have to be contracts. They have to be abstract. Necessarily, I cannot do this. But in abstract classes, I can do that. It's all good, because I can choose which functions I fill in, and I can choose which functions I don't. It's up to the abstract class. This concludes the Inheritance Part 2 video. Thank you.